Hey everybody, I go by Average Gary on the internet. I'm a lifeguard at Mudpool, also known as a software engineer that works on one of the largest solo mining entities to my knowledge. But yeah, we ran a Stratum V2 benchmarking tool, and we're going to kind of go over that, and then we'll kind of cover Stratum V2, the state of the project, the results from the benchmarking that I've ran, and then I'll have like a last slide that's just kind of like my big ideas in the sky where I could see things potentially going. So we'll say this the next generation of Bitcoin mining protocol. Stratum V1 has been around for a while. So yeah, what we'll cover today, like why Stratum V2, why should you care, why does mining care? We'll go over briefly the results I got. I ran a benchmark on testnet 4. If you're on testnet 4, it's being time warp attacked. So very wonky environment to work in right now. If you are the one time warping attacking testnet 4, please stop. Or come talk to me. We can hash it out. No pun intended. We'll overview the Stratum V2 project, like the repositories and some of the adjacent projects related to it. I'll identify just sort of like production readiness here, right? There's firmware support to consider, deployment considerations, and then the last part is like the future implications. That's just more of my personal take on where I see the Bitcoin mining engineering landscape going, especially with Stratum V2. And then most importantly, I think Stratum V2 is ready for production, and if you're into mining, you should care. So yeah, let's get into this. So why Stratum V2, XKCD? Because it's always a good reference. Stratum V1, plain text, it's JSON. It's a raw TCP socket that you can netcat to and shove JSON into, and it will just work. If you know the Stratum URL, you can netcat to that address and that port, and you can start sending it job requests and authorization requests, and there's a whole not standardized protocol for talking to a Stratum endpoint via V1. So that's led to some disaggregated sort of implementations within the firmware. Some firmware doing it this way, some are doing it that way. There's no authentication, right? It's just in plain text, unauthenticated thing. Stratum V2, by contrast, brings a binary protocol. So for those hyper optimization nerds, you have a binary protocol now instead of just plain text. It brings a modular architecture to a variety of different components. There's a formally defined specification document, so you have a lot of interoperability. There's built-in end-to-end noise using the same noise protocol that BIP 324 uses. And then there's an authentication piece, right? So the Stratum V2 URL can add an additional pub key that is a check to make sure that you're talking to the pool or whatever entity you want to talk to on the other end, and you're not being man in the middle by insert bad actor here. And then lastly, there's a Rust reference implementation. We just saw stable channels by Tony written in Rust, BDK written in Rust, LDK written in Rust, Fedimint written in Rust. Like, you get the idea. There's a huge, robust ecosystem of Bitcoin tooling in Rust, and so it's only fitting that what I believe to be the next sort of evolution of Bitcoin mining infrastructure is being built in Rust as well, so we can take advantage of that interoperability. Just as a note, Stratum V2 is actually 3 sub-protocols. So it's a broader protocol that defines 3 sub-protocols. There's the mining one, which like everybody should be familiar with, job declaration and shares and everything. But then, job declaration is its own protocol, and it's a way of negotiating and deconflicting search space, right, between client and server, and making sure that there's not wasted work, making sure that you, down at the site level, can mine on your own block template, and coordinate that with a cloud level like pool or server. And it doesn't, we'll say cloud and site, but it could be anything. And then lastly is the template distribution. So git block template is an RPC command for a Bitcoin node. Stratum V2 brings its own sort of dynamic to that. And we'll get into some of the implications of that on the tech side of things. But that's why Stratum V2, it's a better protocol. Like, I think it's objectively just better. I'd be happy to debate that if you think I'm wrong. So what do we do for this benchmarking? So GitGab19, great dev on the Stratum V2 reference implementation, wrote this benchmarking tool. It is a suite of Docker containers specified in a specific configuration. There's 2 configurations. We use one A, which introduces that job declaration component to it, which allows for template creation and job creation at the site level, closest to the miners. And we'll see the impact of that, right? When you bring things down to the LAN level, any network engineer, any dev could tell you, like if you don't have to go over the internet, you're gonna get significant improvements in latency. And then I updated the benchmarking tool to the latest release of Stratum v2, which is 1.5.0. Just for anybody that's curious, I'll have a link to the full report on my GitHub at the end here. But we ran it on site, like on the mining site, so the miners were talking over the local LAN to this benchmarking tool. But then the components that, like the links between the components that were over the internet had artificial latency introduced, right? So there were some custom proxies that were in between some of these components, and then there was a single process that was pinging a number of public mining pools to gather an average of the latency to those pools, and then it artificially introduced that latency into the connections between cloud and site, right? So that's kind of like the way that this was up, and then Prometheus was used, and then Grafana for visualization and everything. So what do we find? Well, let's go over the architecture a little bit more. You know, your Stratum v2 stack, and this is kind of what was used, is you have your mining devices. Not a lot of them talk Stratum v2, they still talk Stratum v1. So there's a component in there called a translator, go from v1 to v2. That's talking to something called the job declaration client. That is the local, you know, work disambiguator, right? Locally creating block templates. It is actually connected to a template provider locally, a Bitcoin node locally. And then that job declaration client talks to the server. The server is, you know, in the ephemeral cloud. But that server is then connected to a pool that they're also talking to their own Bitcoin node, so there's deconfliction, Coinbase transaction validity, very similar paradigm to like the Ocean Datum project. And then your Stratum v1 stack is like very simple, right? You have a public pool that has a publicly exposed URL, and all the devices just connect to that over whatever pipe. That sort of ignores some like proxying and everything like that, but this is sort of what you get at a very, very basic level, and that's the way that this benchmarking was established. What did I find? Anybody that's in mining, latency is probably one of the biggest, you know, factors. It's a race to find that next block. It's a race to get your block propagated. So in my findings, we saw 19 times faster new jobs. Why does that matter? Like, you don't want to waste time. You don't want to waste hash rate on old jobs, right? So getting those jobs to the miners faster drives more revenue. New jobs after a block, so you might get a new job, but you'll continue working on the old job because it's still a valid block. But when a new block is found, there's a new prev hash that we now have to mine on. So that metric matters because we have to basically flush the cache of the miner every time we see a new prev hash. Otherwise, we're mining on an old block that's gonna be rejected by the network. So we saw 3x improvement there, and then block propagation. Again, when you bring the node to the local LAN, that block can be propagated to the rest of the network quite fast, as opposed to having to go over the internet, arriving at the pool, being validated, and then go to the node to then go out to the network, right? So it's just quite simple, but Stratum v2 makes it easy to kind of realize these LAN efficiency gains when it comes to latency, which are sort of critical to mining operations, right? So you get less wasted hash, your blocks are gonna be built on faster by the rest of the network, and then it doesn't matter if you're just like some pleb miner in your basement, but at a scale, you know, these efficiency gains begin to become more material on the impact to your bottom line and to your operations. Pretty graphs showing it. You'll notice that this bottom left graph, I didn't have data for the first like day or two due to the time warp attack on testnet 4. The public pool, SV1 pool, failed to the jobs down to the miner had bad timing on it. So when we found blocks, the network rejected it. Claude helped me patch that, and we got up and running. So you'll see that on a couple of these graphs that about halfway through, the SV1 picked up and started doing block propagation. Share acceptance, another sort of metric of like how well you're doing. If you submit a share, it can be as stale. And so, you know, more stale shares or less stale shares, more better. So with Stratum v2, we found only 9 stale shares in the entirety of the experiment. Stratum v1, you'll notice that the total shares here, 82,000 compared to 164,000. Again, that metric on the Stratum v1 side is because I had to restart the pool midway through the experiment. But I did run this experiment about a year ago using some older versions of Stratum v2. And I had a 99.7% acceptance rate for shares on Stratum v1. So, and that was a 10-day benchmark I ran back in September of 2024. So I think the findings are still impactful, right? And again, the smallest improvements at scale make a matter a lot. Pretty graphs. You can see the reset in the middle of the left-hand side there. And network bandwidth. So one of the other trade-offs is like your bandwidth consumption. If you're running more daemons at the site level, you're going to have more bandwidth consumption. But I think that is an ideal trade-off to have, right? If you're running a fairly large mining operation that these latency efficiency gains matter, then having more bandwidth is not necessarily a detractor. I will say there's also some ways of kind of tweaking some of the knobs in the configuration to reduce that bandwidth requirement on the site level. But running a Bitcoin node, doing IBD, and having something very chatty is going to increase your bandwidth. So there was slightly higher bandwidth usage at the LAN level from Stratum v2, but you get better latency. But at the pool level, and again, like if you're thinking about data consumption for your AWS account, SV2 was less bandwidth consumption. So that's ideal. And we personally found that the bandwidth versus latency trade-off was favorable for SV2. So now we'll go over the Stratum v2 reference implementation, and this is more of a project overview, right? So there's kind of 5 core roles within the project. You have the pool, which is like the centralized coordinator. The creator of the Coinbase transaction is really the critical aspect there, and then a work disambiguator. That will pair with a job declaration server, which then talks downstream to job declaration client. And those two things, again, negotiate jobs. It negotiates that, hey, you might have your own template from the client, but the Coinbase is good, so like the pool's gonna count it. And then the translator proxy, which is just a bridge until firmware can catch up to us. Just a brief note on that in a little bit. But lastly is the template provider. One of the interesting things about the template provider is, so version 30 of Core released a multi-process experimental feature. So it ships, you can build some additional binaries. You can build Bitcoin-node, Bitcoin-wallet, Bitcoin-GUI. And you can use this thing called IPC, or inter-process communication, to talk over just a Unix socket locally. And so the template provider, Shores, shout out to Shores, has, it used to be within Bitcoin D. It was like a flag -s, some branch that Shores had. But now it is its own standalone repo, leveraging those multi-process IPC interfaces to do all the block template generation. And then one of the things that's different, if you had to call get block template, you're polling, right? Well, now with the template provider sitting there, we can intelligently push new block templates when it makes sense. We can push instead of have to pull. Another thing is, the JDS that should have been, JDS connection loss. The JDC will fall back to solo mining. So when you configure your job declaration client on your local LAN, even if that cloud component, that pool component goes away, you can have a solo mining component. You can actually specify multiple fallbacks for an upstream role for that thing to talk to. So provide some redundancies in your operations, and then ultimately, as long as that local LAN still has connectivity to the broader Bitcoin network, you can continue solo mining with the hash rate on that network. I talked a lot about the modularity. It's an open source reference implementation. When I first got into mining about a year and a half ago, there's like very sparsely populated open source things. CK pool, legendary pool out there, really tried into, battle tested, but not a code base that I'm ready to like level up on. Some resources I list out. I have some more links at the end of the presentation for resources, but stratumprotocol.org, the reference implementation, and then there's a new application. So they're separating out the protocol code from the application code, but the next release will finalize that sort of migration there. So go check it out, but just understand that there might be some rough edges on the application side. Firmware support. There were 2 firmware that I was able to get to connect directly to the Stratum v2 pool that I was running. One was Mara firmware, and the other was Brains. So we do have firmware support for Stratum v2. But if you don't have either of those firmwares available to your deployment, you can just run a translator proxy, right? It's a very, very minimal daemon that runs right alongside the job declaration client or even the pool. It can connect directly to the pool. So you don't need to upgrade your firmware, but you still get the benefits of the end-to-end encryption, that noise, that authentication from your farm LAN to the pool in the cloud. And that's what we use for this benchmarking, just to keep it simple. We just use the Stratum v2 translator. Other projects in the ecosystem that I wanted to shout out, just to show that there's a lot of development going on in mining, and I hope that there's a lot more, is hashpool.dev. If you're interested in that, come talk to the gentleman in front here. Basically, eCache for mining shares. So you can create sort of hash rate places using the eCache protocol. That's a whole separate talk we can go into. Demand.work is a new Stratum v2 only mining pool that stood up. And one of the novel things that, aside from using the Stratum v2 reference implementation code, is they have their own version of share accounting. So there's like a couple different share accounting methodologies. But PPLNS with job declaration, they're basically bucketing if you're mining on a template and you're a jerk and you have empty blocks for whatever reason, and then this other person's mining on a template and they have like nice full juicy blocks, those shares should be weighted differently when we're talking about awarding mining rewards when it comes to pool revenue and such, right? So their accounting methodology takes into consideration the fees and then applies that weighting just to the fees. So like the subsidy, the 3.125 Bitcoin subsidy is like equally shared normally via PPLNS, but then like a juicier block template is going to be rewarded more than a non-juicier block template, if that makes sense. Happy to discuss that. And then there's some other just like service architecture stuff. If you're familiar with the Tower middleware in Rust, it's an HTTP middleware, web middleware. But one of the SV2 devs, PlebHash, is adopting that sort of service trait and applying it to the Stratum v2 framework to drive adoption of the protocol. You just basically implement a bunch of handlers and implement a Rust trait to fill that out. And then, of course, what about Datum? I would be remiss if I didn't mention Datum in a mining talk. So you can go read about Datum. You can go read about the origin of Datum. It does basically the same thing as a job declaration protocol. It allows the template building to happen at the local LAN. I don't know C, so I'm not going to go contribute to Datum. And then also, like I mentioned at the beginning, like the Rust Bitcoin ecosystem is hyper robust. So I can take a lot of these other tooling and apply it to Stratum. I took IRO, which is a hole punching peer-to-peer technology that Fedimint used. I took that Rust library and I shoved it into Stratum v2. So instead of a TCP connection, it's a hole punched IRO connection peer-to-peer. So that will unlock, like you can run a pool at your house and then somebody can hole punch through and connect to your pool and mine with you. Ocean still controls the Coinbase. That's one of the other things that like, it's cool if you can generate your own block template, but like who's getting paid in that block template? And ultimately, like the controller of that Coinbase is the person custodying those funds. You're providing the hash, but they're still keeping those funds. And Ocean is custodial. They will pay you out in the Coinbase, maybe, caveat, asterisk, unless you're Dust or whatever firmware is running doesn't like multiple Coinbase addresses in the payout. Again, a completely nuanced discussion. And then lastly, their accounting, their PPLNS accounting. I've heard rumors that they're going to be adopting some weighting for it, but as of right now, it does not weight different block templates. So if you're mining a block with less fees, you are paid the same as somebody mining a block with a lot of fees. And then some other stuff that I just found cool, not necessarily Stratum v2 related, but somebody's rebooting P2Pool. So P2Pool v2 is coming, also written in Rust, right? So we'll be able to shove Stratum v2 into it when it's ready. And then lastly, Braidpool has expressed interest in using Stratum v2 as well. And again, it's interoperability that we get from the language in the ecosystem. So basically lastly, the imagine if, right? Like so. More open source Bitcoin mining developers, right? I would love to see that happen. I think Bitcoin mining, the ecosystem has largely been neglected from an engineering side. So like more open source Bitcoin mining developments, please. Let's commoditize mining hardware. If you're not following the 256 Foundation and the things we're doing with the BitAxe and the Ember One and providing open source Bitcoin mining hardware design specs and firmware for that, right? Like we're going to commoditize hardware. We're going to put hardware everywhere for hash rate heating. Self-hosted mining, I alluded to this before, right? With IRO hole punching, I can run a pool at my house, and now my meetup can mine to me in my pool. And I can either proxy upstream to another pool, or we can try to hit a block, and everybody gets paid out big. Peer-to-peer mining pools, I mentioned P2Pool being rebooted. Hash rate heating, my basement is going to be finished this winter. Thank you, NGU. But in that finish, I will have radiant heating installed, powered by a Bitcoin miner. So I'll have an M64, I believe, Watts miner, direct-to-chip hydro cooling, and then the hot water is going to go through my house and make sure my wife's feet stay warm. Coinbase games, like what can you do in a Coinbase transaction? Again, like who gets paid in the Coinbase transaction matters. If you're mining, you can do some novel things with that, but not a lot of, like most miners, it's just like one address, and we're just like mining to one address. It's very boring. But if you are privacy-minded, you can roll that address. And again, we have the tools in the Rust ecosystem to enable that. So let's do some more fun things in Coinbase. I want to splice a Lightning channel from a Coinbase transaction. I hear it's possible. It just takes a lot of interactivity. Well, guess what? Mining's online always with a lot of interactivity assumptions already. So like, let's do something cool like that. Permissionless hash rate marketplaces, the eHash, right? So who is pricing your hash rate? When you mine to a pool, you're telling that pool, here's hash rate, please pay me. And there's not much you can do aside from switching to another pool, but ultimately they decide the price of the hash rate. If we can develop better hash rate marketplaces using things like eHash, now your local meetup gets to decide what your hash rate costs. Subsidize your friends, not Ampool. The last one was just deep sea Bitcoin mining. That was a late night discussion talk. Feel free to catch me afterwards if you want to discuss that. These are all the places that you can find me on the internet. Again, Average Gary, lifeguard at Mara Pool. Also part of the Bitcoin veterans. So if you're a military veteran and you're not tied into Bitcoin veterans, come find us. We're going to do a summit here in November. Only on Nostr, occasionally on Twitter under the Bitcoin veterans handle. I run DC Bit Devs, also have my own local meetup. But yeah, it'd be great to talk to you more about mining. And if you have any questions, comments, concerns, please come see me. Thank you.
Any questions?
Well, not so much a question as a statement. No one's going to sell you a nuclear sub, Gary.
No, it's fine. I know the people already running the nuclear subs, right? Like we have submariners and Bitcoin veterans, and we're friends with all the commanding officers of the nuclear subs already. So.
Yeah, take that, Shinobi.